For those of you who follow my videos, you know that a while back I replaced the incandescent bulbs in my Pioneer SX-780 receiver with flex LEDs. They were green. Well, you know, there has been a problem. After, you know, what, a month or so, I guess, maybe a little longer, I decided to open the receiver back up and see what was going on, to make sure everything was okay. You know, I just didn't want to just put them in and leave them. Well, I'm kind of glad I did. Well, I went ahead and I removed the first bulb, and yeah, it came out fairly easy. But the next two flex LED bases would not remove from the sockets. I tried everything to get those things out. The first one came out pretty easy, but the other two would not come out. I had to wind up resorting to pliers. Look what happened here. I used pliers and I pulled and I yanked. Now look at the color of those wires. They're black. I pulled and I yanked, and here's the other one. I wound up breaking one of the sockets. I had to replace one of the sockets that was holding these wedge base flex LEDs. I couldn't believe it. I said, what is going on here? I pulled and I yanked. Well, finally, after I got everything out, what I discovered here, let me get a pencil. I discovered that there was, down in there where those you see those wires, was hot glue. The guy that made these things filled those things up with hot glue. You might be able to see a little bit right there. See it? Well, what happened was they got hot. They got hot, and you can see the dark insulation on the wire, and the hot glue melted. When the wire got hot, so did the hot glue, and the hot glue was seeping out through the holes where these wires came down through. This one right here, and this one, I think there's one on each side. Yeah, see, the glue is still, you can see the glue coming out of that hole there where the wire is. Then the other one is here, and the glue came out, ran down into the socket, and glued the wedge base of the LED into the socket. And that's why I couldn't get it out. I yanked and I pulled and I did everything. I wound up destroying everything trying to get them out. Well, what caused this problem? The three bulbs, incandescent bulb sockets, the wedge base sockets in the stereo were wired in parallel. Okay? And there was a black wire that came up. I think it was like this one right here. It came up to one side of the bulb. Then it went to the second bulb. Then it went to the third bulb. And then we had a blue wire. Let me get this. A blue wire comes up and hooks to there, and to there, and to there. Okay. Now these two wires right here and right here were soldered to a circuit board. They went down and soldered to a couple of connectors on the circuit board. So that's all there was to it. That's all there was to it. And the total voltage, the voltage going to each of these bulbs was 8.14 volts AC. Now these LEDs are rated at 6.3 volts. Okay? 6.3 volts AC. We were running these things, you know, almost 2 volts over. You can't do that. And even if it was 1.5 volts, it wouldn't have been enough, or even 1 volt would have been a bummer. The reason being, if this had been a 12 volt setup, you know, and you run it over by 1 volt to 1.5 volts, maybe even 2. I mean, that's really pushing it. It probably would have worked fine. But we weren't doing that. We were running way too high for this 6.3 volt bulb. And they caused them to run hot. We were running what? Almost 30% over. Can't do that. So what I had to do, how do we solve it? How do we cut the voltage down to 6.3 volts AC? Well, I got together with my old buddy Brendan. I had it figured that the resistance would be a little bit too high. And he said, nah. He said, I'll tell you what. He said, go ahead and start with about 25 ohms. Put a resistor in the line, you know, right here. Just kind of cut it. Put a little resistor right there. And that'll cut down the voltage, and let's see what that does. Well, I didn't have a 25 ohm. I had a 22 and I cut it down. I wound up getting the voltage down to 5.5. I think it was 5.54 volts AC. But that made the bulbs too dim. That sucked. Couldn't do that. Had to go back up. Anyway, I wound up with 15. I put in 15 ohms, and that still didn't quite give me what I wanted. And we wound up with 12 ohms. I put a 12 ohm resistor here, a half watt, in the blue line. And that cut the voltage down to 6.03 volts AC. Works great. Each of the bulbs now has 6.3 volts AC. Works great. And the I ran the bulb. I replaced the bulbs with different ones. The flex LEDs. I put new flex LEDs in there, and I ran them for about an hour, and then took a temperature reading on the LED itself. Right here, I got 77 degrees Fahrenheit on each one. Now it would vary, you know, a quarter of a degree either way on the digital thermometer I was using. I used that LED. I used that thermometer. It has the laser, you know, and I shined it on. And on the back of the circuit board, on the rear, where these little components are that you see right here, those things were reading 84.5 degrees all across the board. Okay, so now we've got our temperature down. The light is great. Nothing is burning, getting real hot. Nothing is melting out of the bottom of the wedge base and cementing the base to the socket. By the way, when you take your voltage readings to determine the amount of resistance you need, make sure each of the LEDs is in the socket. Take your voltage readings with the LEDs in the socket. Otherwise, you get the wrong reading. Anyway, this is what we have now. Is that cool or is that cool? Yes, it is. Good stuff. I love this color. This is really nice.